So I'm joined here today by Arcanum's new product introduction and marketing director, Adam Thomas, and their product marketing analyst, Ashley Canasti, for Quimey's second interview as part of our ongoing intelligence series. Adam and Ashley join me today to talk through Arcanum's new electrical steel grade and share some further information about the company and its next steps. So thank you for joining me both. To begin, can you just tell me a little bit more about yourselves and your experience within the industry to date?
Sure. My name is Adam Thomas. I have approximately 8 years in the steel industry, all of which were spent at Arcanum Alloys. The company was founded about 8.5, 9 years ago. And so I came from a chemical and material processing background, spent some time in aerospace and defense prior to Arcanum, and really bring I guess, a broader look at what products can be developed by the company for the team.
Thank you. And Ashley?
Yeah, hi, I'm Ashley Canasti, and I joined Arcanum Alloys in June of this year as part of the product development team. And before that, I worked for a global chemical company for 7 years, where I specialized in metal pretreatment, focusing on the automotive sector.
Perfect. Thank you very much, both of you. So thank you again, both of you, for joining me. So to begin, I think it is right that we talk through a little bit more about who Arcanum are. So you're a steel specialist with products catering to a wide variety of different industries. For those that are watching at home that might not be familiar with the company, can you tell me some more about what you do and what your mission is?
Sure. Before Arcanum, the steel industry hadn't really seen a fundamental change in the steel production process since Bessemer. That was, I think, a little bit over 170 years ago. Effectively, the traditional process has been take dirt and rocks, melt them down, remove impurities, and add alloying elements to the melt, and then you cast that and roll it or draw it into a useful form factor. The scale at which that happens is, it's staggering. If you've ever been to a mill, it really is something to behold in terms of the scale at which they're doing this. But that said, it's still flawed, and it's flawed because it forces steelmakers to produce very specific products, and those products aren't able to change all that much without massive expenditures in capital equipment. The mills are really beholden to their capital equipment for what they can make. Arcanum's process challenges the assumption that the alloying elements should be put in during the melt. Effectively, we take a low alloy grade and bring it towards its final form factor and then alloy it. So instead of doing it in the melt phase, we do it after it's been formed into a semi-finished or a finished product. We call that platform that we stand on spatially optimized diffusion alloying, or SODA for short. What SODA does is it offers a number of advantages over the traditional process. There are 2 critical advantages. The first one is that we make alloys where the alloying elements are placed only at the surface, and a lot of times that's where they derive value. Think of stainless steel, for example. Stainless steel derives value from being stainless at the surface, not necessarily from being stainless in the middle of it. And the second advantage is that we can make alloys that aren't castable or formable at scale by today's traditional process. And so you take those 2 things and you actually are causing quite a disruption in the industry. We demonstrated the spatially optimized diffusion alloying on a stainless product first. We call that Optiform. It's a highly corrosion resistant steel with excellent formability. And then we are demonstrating right now on our second product, an electrical steel product called OptiCore that we're here to talk about today.
Okay, perfect. Thank you very much. And for our next question, I'd like to move on to talk some more about the new electrical steel grade that you just mentioned.
Yeah. All right. So as Optiform, our initial product, began to wrap up on the development side, we decided that we needed to look at what other steel products this platform technology could be applied to. During that process, a lot of either customers or mills would ask us, can you do electrical steel? Can you do electrical steel? And what they were asking that for is because as the automotive sector undergoes electrification, you're seeing what is effectively supply being outstripped by demand. And as the higher quality electrical steel is consumed, then all that leaves is lower quality electrical steel, and that leads to inefficiencies. And customers, whether they're OEMs making automobiles, or if they're making small motors for aerospace or medical applications, they're not looking for lower grade. They're looking for higher and higher grade for higher efficiencies. And so that's what we decided to move into. And what we do to do this is we take the alloying elements that are associated with high quality electrical steel, silicon and aluminum, and we impart them into the steel.
Okay, that makes sense. And is there any particular technology that makes this possible? How do you accomplish this?
Sure. So as I mentioned, the silicon and aluminum are what improve the performance of electrical steel, typically from an alloying perspective. And so what we do is we take a really clean grade of low alloyed steel, has very little silicon or aluminum in it to start with, but is also fairly clean. So it doesn't have carbon, nitrogen, sulfur, the things that will also hurt performance for electrical steel. We take a coil of that and we coat it, and then we run it through our process, which is a high temperature process. During this process, the coating, which contains silicon and aluminum, is actually imparted into the steel, and therefore the alloy content of that steel increases. And specifically for those alloying elements, that reduces what they call core losses. And core losses are basically heat that's wasted during the operation of an electric motor or transformer.
Any specific advantages that are offered by this technology?
Absolutely. SOTA provides engineers with the freedom to design for product optimization without worrying about the typical trade-offs. So, for example, when selecting the type of material to use for a given application, currently engineers have to compare the pros and cons of each material. But Adam has, as Adam has touched on, by having the ability to separate the surface from the bulk properties, our SOTA technology helps to reduce and eliminate the trade-offs or cons. So for OptiCore, we're able to offer high alloyed electrical steel that reduces core loss without sacrificing induction or becoming brittle.
Okay, and you've both mentioned the EV market. Are there any other markets or areas that you really see, obviously the revolutionary technology and the process involved, having an impact going forward?
Absolutely. So, automotive is the big one because it's it's a large market to start with, but it's growing rapidly, and so that's what most people focus on, and certainly that's what we're looking at as well. But we're also looking at other smaller markets. We're looking at things in aerospace and consumer appliances. There are many places where electric motors exist, obviously, in the world, and our technology provides an improvement for all applications. Really, it's just about optimizing from a market entry standpoint. We're looking at lighter gauge materials. So things in aerospace and medical where high frequency applications exist. That's where we're starting first because that's where we provide the most value. But this technology is fairly ubiquitous for electrical steel, and so we can expect to be producing products all throughout the market.
And we've just been talking about the automotive or the electric vehicle industry. As you mentioned, it is rapidly growing, and I think it's the sort of the subject area that a lot of our audience will be most interested in. So can you give me any more examples about how exactly OptiCore will advance the developments in the field? How will it continue to help the industry progress?
Sure. Transition to electric vehicles is already taking place, but consumer adoption is a key factor. So one of the main EV deterrents is consumer range anxiety, and therefore motor efficiency is a main priority. It's been proven that the tiniest motor efficiency improvements have led to an increase in range. So as I mentioned earlier, the advantage of OptiCore is that you can achieve a reduction in core loss without sacrificing induction. Simply put, by using OptiCore, you will need less power to generate the same desired torque, which subsequently extends the battery life. Engineers the option to either extend their electric vehicle's range or to reduce the battery size if reducing weight is more important to their design.
So as you mentioned then, Ashley, it is forecasted that the adoption of electric vehicles is going to continue to grow. Industry is actually concerned that they'll only be able to meet 60% of the market needs. Do you see any benefits for component manufacturing service providers where demand is outpacing supply?
Yeah, absolutely. So right now, the supply of electrical steel is limited by production capacity. The reason being that traditional electrical steel production requires heavy infrastructure investments. And unless steel manufacturers have guaranteed volumes, they're unlikely to make that investment. So our technology eliminates that risk and provides steel manufacturers access to a market that without major CapEx investment be available otherwise. Since our process applies the essential alloying elements during the semi-finished phase, steel manufacturers now have the ability to produce high-quality electrical steel using their current equipment. So theoretically, every steel manufacturer has the ability to produce OptiCore with their current equipment. Implementing our technology would be a great step forward to resolving, the market's future supply and demand challenge.
So how does OptiCore assist in the resolution of these existing market demands?
Yeah, so OptiCore specifically is a technology, and as Ashley mentioned, mills can use this technology to supply electrical steel, or any other product for that matter that we come up with using technology. And specifically, Arcanum is currently working with multiple mills to license this technology in North America, Europe, Asia, etc. So there's this possibility of spreading the technology globally with relative quickness.
And what gauge sizes do you offer when it comes to OptiCore?
So OptiCore as a technology can be demonstrated at any gauge where electrical steel is made. Right now, though, we are focusing on the lighter gauges. So basically 0.25 millimeter and below, all the way down to 0.1 millimeter. And these are considered fairly light gauges, but this is where the highest performance is achieved in high frequency applications, which is where we derive the most value for users. That said, looking forward, we'll be looking to supply this at 0.35 millimeter, 0.5 millimeter, and greater.
Okay. And I think another area that people at home might want to hear more about, especially when it comes to the topic of the electrification of the automotive industry, is the environmental side. Are there any environmental effects that you've seen from this technology?
Absolutely, and especially with something as ubiquitous as electrical steel, the environmental effects not only are greater efficiency and therefore less wasted energy, but you start looking at the system where it operates in, and then you can start reducing the size of a battery, or you can start reducing the weight of the car. Things of that nature have far-flung effects that are really difficult to quantify. But anytime you can make an improvement in something as basic as the electrical steel around which the motor runs, you're going to see a positive environmental effect as well.
And I think just to close up for the interview, is there anything more that you can tell me and the other people that will be watching this at home about what is next on the radar for Arcanum?
As I mentioned, it's a really fundamental change to the process through which steel is made. And so we're surveying a very, very wide landscape. And we are looking at how we can make the most impact quickly, both for our customers, for the industry. It's really important that we work on the right things. And so that's what Ashley and I are working on a daily basis, is where to next, because now that product number 2 is wrapped up, we're looking at product number 3. We're looking at things like low density steels. If you can make the weight of the steel reduce by 10% without changing the other properties, now you're talking about 10% less weight in every application you have. We're looking at wire, other form factors. We're looking at additive manufacturing, all sorts of different avenues and how we can use this technology. Like I said, it's a platform technology. It's not just silicon or aluminum or chromium. It's most of the metallurgically important alloying elements on the periodic table are possible to control using this technology. So it's pretty exciting time to be at Arcanum, and we definitely appreciate the chance to talk about it here today.
I appreciate you both coming on, and thank you both for answering all of my questions today. And I'm excited to see what will come from Arcanum in the future, and hopefully we can have you back as part of the Kwame platform to talk about it then. At home, you'll be able to watch this and our other upcoming interviews on the Kwame website, or as part of the latest Kwame Intelligence email, which should be arriving in your inbox on October 23rd. So just to close out, thank you again both to Ashley and to Adam, and we'll see you in the next interview.
Thank you.
Thank you. Thanks, Liam. Take care.